Welcome back to Concepts in Arithmetic. We are going to continue our discussion of divisibility tests. In this video, we will talk about testing whether a number is divisible by 3, by 9, and by 11. As you'll see, they're all very similar tests. Okay, let's start with divisibility for 9. Scoop myself out of the way here, right about there we'll do it. So a number is divisible by 9 exactly when the sum of its digits is divisible by 9. And if we look at a couple quick examples, we could apply the test to, say, 319. The sum of the digits there is 13. 9 does not go into 13 evenly, so we can rest assured that 9 will not divide into 319 evenly. This number, on the other hand, 7,452, if I add up the digits, 7 plus 4 is 11. Oh, that's not true, is it? Oh, it is. 7 plus 4 is 11, plus 5 is 16, plus 2 is 18. The sum of the digits is 18. 9 goes into 18 evenly, so 9 will divide into 7,452 evenly. Okay, so let's talk about why this test works. So we'll do a little proof. Consider the 4-digit number, and we'll just make a generic 4-digit number A, B, C, D. Okay, A, B, C, and D are the digits. I'm going to kind of write this out in expanded form. A, B, C, D is equal A times 1,000, right? That's the digit in the thousands place, plus B times 100, that's the digit in the hundreds place, C times 10, and finally plus D. Okay, now we're going to rewrite these a little bit. So instead of 1,000, I'm going to think of that as 999 plus 1. Instead of 100, I'm going to think of 99 plus 1. Instead of 10, I'm going to see that as 9 plus 1. Okay, now I'm going to use the distributive property, and I'm going to do some rearranging. Okay, so of course when I distribute here, I would get 999 times A plus 1 times A. And 99 times B plus 1 times B. So I got the 999A over here, and then I got the 1 times A over here. I kind of collected everything that had just the singles. Okay. Now here's the point. This is definitely divisible by 9. This part of the sum has to be divisible by 9 because 9 goes into this, 9 goes into this, and 9 goes into this. So 9 will divide that total. So by the divisibility lemma that we talked about in the last video, I've got a total of 2 numbers. This number is divisible by 9. The total will be divisible by 9 exactly when this other number is divisible by 9. So, my total will be divisible by 9 exactly when A plus B plus C plus D is divisible by 9. Well, if you look up here, that's exactly what the claim was. A number is divisible by 9 exactly when the sum of its digits is divisible by 9. Well, that's our number. We just wrote it out in this expanded form. So our number is divisible by 9 exactly when this total, the sum of the digits, is divisible by 9. So it's a very quick way to check if a number is divisible by 9 without having to do the long division. And I would also note that if you remember casting out 9s from grade school, that's where this comes from. Okay. Okay, so we've got divisibility by 3. And the test for divisibility by 3 says a number is divisible by 3 exactly when the sum of the digits is divisible by 3. Now the proof would be the exact same proof that we used when we were establishing the divisibility test for 9. And the reasoning is when we did this rewriting, well, yes, that's divisible by 9. It's also divisible by 3. So if I break the number up in this exact same way, I'll have one part here that I know for sure is divisible by 3, and then I'll have this other part, which is the sum of the digits. So the total will be divisible by 3 exactly when this second part is. Okay, so that same proof works for both. Kind of nice. Now, the divisibility test for 11 is a little different. Okay, so we have two tests that work the exact same way. You want to test if your number is divisible by 9, add up all the digits. Check that sum. Is that sum divisible by 9? If so, your number is. You want to check whether your number is divisible by 3, add up the digits. Look at that sum. Is it divisible by 3? Now, 11's a little different. A number is divisible by 11 if the alternating sum of the digits is divisible by 11. Okay, the alternating sum. And let me just do a quick note here about what I mean when I say an alternating sum. If I did something like A minus B plus C minus D, where I had, those are any numbers I want. Okay, I'm going minus, plus, minus, plus. That is what I mean by an alternating sum. Okay, so let's think about why this would work here. Let's talk about a proof for this divisibility test for 11. Okay, So we're going to take a 4-digit number, A, B, C, D, and we'll write it out in expanded form. Okay, A is the thousands digit, B is the hundreds, C is the tens, and then we've got D. All right, now, when we were doing the proof for divisibility by 9, we viewed this as 999 plus 1, and then broke it up that way. Now, the whole point of doing that is that we know 999 is divisible by 9. Okay, that won't work here, though. 11 doesn't go into 999 evenly. However, 11 does go into 1001. So instead of viewing this as 999 plus 1, I'm going to look at it as 1001 minus 1. Now over here, 11 does go into 99, so I'm going to view the 100 as 99 plus 1. Okay, now over here, I'm going to bring in an 11. So instead of seeing a 10, I'm going to do 11 minus 1. Whoops, I'm in the way. Let me scooch over here to the left. Okay. So if I break everything up, I'd have A times 1001 plus B times 99 plus C times 11. And now the leftover parts, the singles, would be minus A plus B minus C plus D. Okay, now this is guaranteed to be divisible by 11, this first part. So, once again, falling back on the divisibility lemma, the total of these two, which is equal to the number that we started with, the total of these two will be divisible by 11 exactly when this alternating sum is divisible by 11. Okay, so let's look at a couple of examples of that. So we're looking at a couple numbers here. We're going to apply the divisibility test for 11. I actually like to start on the right end, so plus 8 minus 2 plus 7 minus 2. Okay, so I'm going to do this alternating sum. So minus 2 plus 7, that's a 5. Minus 2 is a 3. Plus 8 is 11. And of course that is divisible by 11. So the original number is divisible by 11. Oops. You don't have to start on the right like I do. You can start here and do plus, minus, plus, minus. You just have to realize that you might get a negative when you do that, so you have to be okay with dealing with negatives there. All right, let's look at this. So, plus 5, minus 1, plus 4, minus 1, and plus 3. Okay. So we're looking at this alternating sum of the digits. So 3 minus 1 is 2, plus 4 is 6, minus 1 is 5, plus 5 is 10. Of course, 10 is not divisible by 11, and that means that this original number is not divisible by 11. Okay, so a couple tests that involve looking at the sum of the digits in your number. If you're talking about divisibility by 3 and by 9, you look at the plain old sum of the digits. You take the digits in your number, add them up. If that sum is divisible by 3, then your original number is divisible by 3. If that sum is divisible by 9, then your original number is divisible by 9. When you're talking about divisibility by 11, it's a little trickier. You got to do this alternating sum. And then look at that. If that is divisible by 11, then your original number is as well. So kind of the same spirit, it's just that we build the sum in a different way.